So let's try one more example with the multiplying of decimals, connecting it to, representing it with the base 10 blocks, and then connecting it to the standard algorithm. And I want to compare and contrast. Actually, it'll be kind of like an example and a half. So let's try one without a whole number. Oh, that's a little too high. Let's try 7/10 times 1 and 3/10, should we say? So same idea. Let's set that up, right, as this idea of area. We're looking at the space inside of here. And that's how we can see the dimensions from the left side and the dimensions from the top. So you can choose, maybe we'll say this at the top. Nope. Is our 1 and 3/10. And this would be our 0 and 7/10. So go ahead again, try this before I do it. Pause the video and set it up. We're going to, again, continue to say that the flat, right, just like with fractions, we're going to define our whole, right? Our flat is 1. And then, so 7/10, 1, 2, 3, oopsie, wrong one, 4, 5, 6, 7. And so we look across. We want to find the space in here. So you can think about it as, and we can even do the partial products down here, right? 1 and 3/10 times 0 and 7/10. The same idea. 1 times 0 will be 0, but 1 times 7/10 is going to be, and I should put the decimal point there, maybe 7/10. And so we can see that step here, right? 1 here times these 7 here. Maybe that's what we'll do, right? Will just be those 7/10. And if this was 2, right, say we did 2 and 3/10, we could do, right, 2 times, and I see I made a typo here, 7/10, not 7/100, was always the intention. Then we'd see this, 7/10 literally one time and then a second time if there were two holes here. So that's a really important connection to see that this, right, the numbers, while it, 2 times 7/10 would be, right, how many rods would it be here? Oops. Sorry, that erased this line. Right, how many rods would it be? It would be 14. And so when we think about 2 times 7/10, and we can see that as 14 rods, where a rod is 1/10, right? We see it as 14/10. So this is, again, the power of these manipulatives, or even the representations, because we are seeing how we get these, the procedures. Because if you think about it as just 7/10 times 2, or, I know, again, our procedural understanding is 7 times 2 is the same as 14, and then we count how many decimal places. But if you're like me, that never made sense, right? Why does that work? Why do we count how many decimal places? How does that tell us what we need to know? And here, if you are introducing multiplication as area with the blocks here, you can start to develop that reasoning without ever needing to even say that out loud. Your students will, discover that on their own. And then now we're going to look at this. Here's 1/10 times 1/10 from here, right? And so what I want to do is show you down here. I know this, don't think of this as part of the array, but if we were had the physical manipulatives, I would have you do, right, a rod on top of a rod, and then you can see, right, this overlap. What is this area times this area, right? This space right here. It's this space right here, right? This 10th times a 10th. And so in the last video, I wasn't sure if that was completely clear. So I wanted to really highlight that aspect of, the overlapping of rods and where this 1/10 times 1/10. And again, if you write it in decimal form, 1/10 times 1/10, it might not be clear why that's 1/100th. But if you write that as fractional form, and now that we've had all of this fractional understanding, right, 1/10 of a 10th, we can see why it makes it smaller, right? We're taking a piece of a piece. And then, or even understanding the fractional, procedures, multiply the numerators, multiply the denominators, right? It's 1/100th now. And so for me, the base 10 blocks just help to really show why and how that is. And so now we think about it, maybe not as 1/10 times 1/10, but maybe like here in our open array, what about 3/10, right? And maybe we'll make those additions, right? 3/10 times 7/10. We're going to have a 3 by 7. Yeah. So how many pieces fit in here? Or how many of these 3/10, how many times do I want that? Yes, you got it. Yeah, 7. And we can see that because of this area array model that we're using. So we want it 1 time, 2 times, 3 times, 4 times, 5 times, 6 times. Oh, sorry, that got 7 times. And so, yeah, just by understanding this area model, we didn't literally have to make all 21 of them. You already knew that. And so here we can think about this as 21, but is this 21 hundredths? Is this 21 tenths? And that's the question. How do we know? Well, right? If we look at our diagram, well, we said that the flat, right? This guy, the flat here is 1. So that means our rod is 1/10, and that meant our unit cube, right, is 1/10 of 1/10, or 100th. Sorry, the pen in this app is not cooperating today. And now we can see with 21 hundredths, we can make one group, and here down here is how we've grouped them, right? One group of 10s, and here let's erase, and now we can rearrange. One group, and then we have 3, 6, 9, 10, another group of 10s. And now we see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 100th, right? 7/10 plus 21 hundredths is, 91 hundredths, 0.91. And maybe you didn't think that you would be able to find do this multiplication up here. But also reason about, right, if we're thinking about the standard algorithm, where we line up the decimals in a more accurate way than that, and we do, 7 times 3. And again, that language of 7 times 3 is so misleading because it's not a 7, it's not a 3, it's 7/10 and 3/10. And then so 7/10 times 3/10 would be our 21, and then 7 times 1 would be 7, 8, 9. And now again, Okay, so we saw, where did we see the 7 times the 3/10? Where did we see the 7 times the 1? Or again, 7/10 times each of those pieces with the blocks. And how do we know then where to put this decimal place besides just counting these decimal places? Well, clearly we can see that with the blocks. Excuse me, sorry. Or we can reason about these numbers. Well, 7/10 is less than 1, and 1 times 1 and 1 and 3/10 would be 1 and 3/10. So it has to be slightly less than 1, right? It couldn't be 9 and 1/10, right? The decimal couldn't go there, and it couldn't be 91, and it couldn't go further, right? It wouldn't be that much smaller than 1. So reasoning about the size of the numbers is going to also help us know where and how to place the decimal point.